a bunch of enthusiasts who already has like a background in computer science and technology mostly. So as a team, if we have to take like one problem and solve it, is there anything in the QKD domain? Because the last slide that you showed also, like QKD is one area that the adoption has been growing, at least at the industry level. So what would you suggest, ma'am? So on research side, higher order computing, those things.
Sure.
On let's say someone is thinking about a startup in this domain, quantum cryptography, then what would be a good area to explore or a use case to explore?
Yeah, this is something I would need to think a little bit more before I can give a well thought out answer, because it could change. But then, of course, as I just said, that I think one of the things which so one of the problems with some of the startups which exist is that they are focusing on certain protocols which beyond a point do not have the right security analysis. Like, for instance, you will hear about something called differential phase shift based QKD, PSQKD, which is actually using it's a fiber-based system, but it is actually using a weak coherent pulse. And I actually said during the talk that if you want, we can discuss it a little bit more. So then the idea is that you have a laser, and then what you're doing is through some means, you're attenuating it down so that you reach a domain where you have less than 0.1 photons per unit. Okay. So in some sense, the essential idea is that you are reaching a domain where you can say that, okay, maybe in this pulse, I actually do have a single photon. But the problem is that, this is an average. So then there are going to be pulses in which you have multi-photons. And there are going to be pulses in which you have no photon. That is the one which will make this number go down to this 0.1. So this weak coherent pulse-based source has this inherent issue that it is statistically not a single photon source. So if you actually try to do this anti-bunching experiment, which is what we do to get the single photon character, where you have these, it's called the Hanbury-Brown twist experiment. It's also using cosmology. So you have a single photon incident on a beam splitter. It'll either go forward or it'll be reflected. It can't go both because it's one entity. So if you try to do a correlation measurement between these two, you will not get anything because it's gone this way, but here it is 0. So 1 times 0 is 0. And so that is the basis for Hanbury-Brown. So this is where, you get a dip in this exercise, which you won't get using these other types of sources. Okay. So then if you use a WCP, that doesn't mean that you can't, you can use it. But then the problem is with this GPS type systems, they have a security analysis issue. So it would be nice if people actually concentrated on more established protocols, because there the security proof is very well known. But in order to do that, you need to do real photons, and that is perhaps why people don't do it in the first instance.